These are your notes on inequalities, so the title can just put inequality notes. To start, inequalities will work just like equations, except instead of everything being balanced, like in an equation, it could be unbalanced. The four symbols that you've seen before, the first one is the greater than symbol. Next we have the less than symbol. The third one is your greater than or equal to. And the fourth one is your less than or equal to symbol. With inequalities, once you solve them, you need to do a graph of your solution. The first two symbols are less than and are greater than symbols. We're going to represent those with an open circle. Okay, it means that we could include any number up to that number or any number below that number, but it doesn't include the actual number within the inequality. The next two, those ones are going to be represented with a closed circle. That means it could include the number that is being graphed. Just as an example, we're going to graph x is greater than 2. So at the number 2 on the number line, we're going to do an open circle, and we're going to show all of the numbers that are greater than 2. So 3 is greater, 4 is greater. That's the side that we're going to shade with the line. All of the numbers on the other side are less than. Those would not be solutions of the inequality. Okay, as another example, this one says that 5 is greater than or equal to x. We could also write that as x is less than or equal to 5. So if we reverse everything, kind of like a mirror image, we can rewrite it if that helps. We're going to have a closed circle at 5, and x is everything less than or equal to 5. So it could be 4, 3, 2, it could be negative 10. So we're going to draw a line with an arrow showing that it goes on and on forever down the number line. Okay, as I mentioned before, inequalities are going to work very similar to equations, so we can solve them the exact same way. In this inequality, I'm going to start by subtracting 3 on both sides. So I get 2x is greater than or equal to 8. Divide by 2. And I get the inequality x is greater than 4. Now that means any number that's greater than 4 will be a solution to this inequality. Let's do a test. So if we do a check it step, I'm going to pick a number greater than 4. Let's just pick 5. And I'm going to substitute that in and solve to make sure it works. Okay, when I do that, I get 3 plus 10, and 3 plus 10 is greater than 11. That's a true statement. And so because it works, I know I'm going to shade the side of the number line that has 5. Okay, just to contrast, if I picked a number that was less than 4, let's say 3, and I substituted that in, now when I solve, I'm going to get 3 plus 6, which is 9, and 9 is not greater than 11. So that's false. That means I am not going to shade the side that has 3. So that means that on the number line, open circle at 4, all of the numbers going to the right with an arrow on the end. Okay, there is one exception with inequalities. All of the rules that you've learned so far work. There's one kind of funny thing that happens though. If I multiply both sides by -1, I'm going to get -5 and -4. Now we have a problem. -5 is not greater than -4. That's a false statement. -4 is greater than -5. So anytime you are multiplying or dividing by a negative number, instead of keeping the inequality symbol the same, you are going to flip it. So we're going to rewrite this as -5 is less than -4. and that is a true statement now that we have swapped the sign. So notice right here, instead of greater than symbol, we now have the less than symbol. Okay, so an important piece to put in your notes: anytime you multiply or divide by a negative, you must flip your inequality sign. So if we do an example that has a two-step inequality, we can see what that looks like. I'm going to subtract 5 on both sides. Here's my 0 pairs. Negative 3x is less than 9. This time I'm dividing by a negative number. Divide by a negative number. So I get x is greater than negative 3 because I flipped the symbol. So the graph of that open circle at negative 3. And I want to show all the numbers that are greater. So draw the line to the right with an arrow. Now let's just test it to make sure that this works. Start with the original. 5 minus 3 times, let's use 0. 0 is an easy number. Should be less than 14. 3 times 0 is 0. 5 minus 0 is 5, and 5 is less than 14. So we get proof that when we flipped it, it helped us make the inequality correct or make it true. Just to compare, I'm going to do another number that is not in the solution set. So let's use negative 5. So if I do 5 times 3 times negative 5, we'll check and see if that's less than 14. So we get negative 15, 5 minus negative 15. So keep add opposite, and I get 20 is less than 14. That is false. So that means that negative 5 is not part of the solution set, so I should not shade the side that has negative 5. All right, final example. This time we're going to set up an inequality to represent the word problem. It says you want to purchase a bicycle that costs $265. So far you have saved $128, and you plan to save an additional $20 per week. First, we're going to write an inequality to represent the number of weeks it will take to save at least $265. The number of weeks is what we're looking for. So let's just set up our variable w equals number of weeks. Okay, the other piece is we have to get at least $265. So the at least part, we could have more than $265, but we have to have a minimum of $265. So whatever we save has to be greater than or equal to 265. You had $128 to start, and you're going to add in an additional $20 per week. So there's your inequality set up. Now you need to solve it. So we can subtract 128 from both sides. I'll rewrite it over here. 20w is greater than or equal. Let's find out what that is when we subtract. So to $137, divide both sides by 20. And after we divide, we're going to get W is greater than or equal to 6.85 weeks. Okay, so when we think about this, if we're getting $20 per week, we're probably getting $20 at the end of each week and not some of that $20 each day. So we're going to need to round 6.85 up to 7 and say that you need to work at least 7 weeks. That'll give us just a little over 265, but it'll be the minimum. Now when we graph it, we're going to graph the exact solution that we came up with. So let's set up our numbers 5, 6, 7, and 8. So at 6.85, so somewhere right around here, we're going to do a closed circle, and we have to work at least that amount, so we could work any number of weeks greater than that. To answer part B, we will not have enough money after 6 weeks, but we will have enough money after 6 weeks. So if you were answering that on a test or a quiz, you'd want to use a complete sentence and say, no, you will not have enough money after 6 weeks, but yes, you will have enough money after 8 weeks.